Good afternoon, everybody. Welcome to another exciting afternoon of Chem 170 with your host, me, Dr. White. Now, hopefully you've been checking your email, and let me check my glasses, and you would have seen that on Saturday, I sent out a email telling you your test number one scores were in D2L. And also a little after that, I individually emailed each of you with the points for each answer on test number one. In a little while, we'll go through test number one answers because in my class, a student should never, ever, ever be penalized for a mistake I make. If I make a mistake, tell me, I'll correct it if it's a mistake. And we'll go through test number one. All right, important information. What is an announcement? All right, because of the lack of attendance in my office hours, and also this week is the Stanley Cup Finals, for this week only, I'm going to move my office hours to 5 to 6 p.m. Monday and Wednesday. I'll be moving at 5 to 6 p.m. this Wednesday. Now, last semester, it worked out that time at what I used to have at 6 to 7 quite well. I'm going to be sending out an email today or tomorrow, and I'm going to ask I'm going to give you some choices, which office hours would be better. And I'm thinking because the 6 to 7 on Monday, Wednesday, just a number of people told me they're working on that. So I'm going to be moving that because I'm having office hours to help you. All right, what other things we're going to do? All right, we're in a good shape where we are on the schedule. So today, excuse me. Today, that got it. Oh, no, not yet. But anyways, hold on one sec. I apologize, but sorry, I had to clear my throat. Let me check. Cyclohexane, it works. Anyways, today, I'm going to be going through test number one. We'll go through new material on aldehydes and ketones, and then afterward, we'll have our lab. And if we were face-to-face on a Monday, Wednesday in the summer, I teach from 1 to 1:50, take a 10-minute break. We'll only take a 5-minute break. And then I'll come back and do the lab. And since you're not actually doing the lab in the lab, because you're at home, you're going to get out early. And this is what we're going to do the rest of the semester. And you're getting the same face time. All right, let me tell you about test number one. First of all, you guys did good. You're learning organic chemistry. You should be proud of yourself. The average was, let me look, 91 out of 105 points. Don't forget it's 5 bonus points, so it's really 91 out of 100, which is quite good. A lot of you did very good. What I'm going to do is go through the test. Now, do not ask while I'm going through the test now, why did you take off these points on this question or that? See me after class or come to my office hour. And if we were face-to-face, I'd do the same thing. Excuse me. I hope I'm not coming down with a sore throat. Nope, I'm not. But anyways, if you have a mistake, either after class today or email me or come to my office hours and I'll check it because I've got your test downloaded so I can check it. And if I make a mistake, yes, I do correct it. Now, a couple things how I grade. On nomenclature problems where you're to give the name, if you get the root, chain, or ring wrong, you get 0 points, even if you have the alkyl groups right. That's just the way I do it. Now, if you get the alkyl groups are the front, you got the root name right, but the other part you got wrong in any way. They're all 3-point. I'm not going to do half points. So you get 1 point. This is the way I do it. On a rare occasion, if you got one number, I'll give you 2 points. That's very rare. On reactions, it's either right or wrong, 0 or 3. Unless you make a hydrogen mistake, once in a while I'll ignore it, or this test, I think I might have taken off 1 point. But if you have a structure and it's supposed to go to this carbon, you have it going to that one, if it's not the right structure, it's wrong, don't ask for partial credit. This is the way I grade an organic. All right, let's go through the test now. I should mention that I will be cutting this out of the video. If you'd like to see it again, or if you aren't here, I will be always available to show it to you during my office hours. And thumbs up, people. You see, test number 1. All right, now, one of the things, if I were in your shoes, I would be asking, well, what's my grade right now in this class? Well, let's forget about the labs for the time being. If you look at test number 1, if you got 90 and above, you're getting an A. 80 to 90, B, 70 to 79, C, and so on. It's in my syllabus, that breakdown. However, remember the lowest test score is dropped. So everybody has the ability to still get an A. Doesn't that make you feel good? Yay, but you guys did good, which makes Dr. White feel good. Thank you, and thank you. Now you know what I mean by practice problems. Hopefully that all helped you practice for test number 1. All right, any questions about test number 1? Looking at the chat. All right, we got some time to go to ketones and aldehydes. All right, I think it was Thursday, we were doing this reaction, and let's go through it again. You did some, but let's do it again. If you react a ketone or aldehyde with alcohol and acid, if R prime is H, it's a ketone. If R prime is alcohol, it's it's R prime H, it's a aldehyde. R prime H, alcohol is a ketone. Let me rewrite this. And if R prime is H, it's an aldehyde. If R prime is carbons, it's a ketone. And keep your eye on the carbonyl carbon, because that's where the fun is. What's attached to it in this reaction is still attached. And then this becomes an alcohol, and actually not an alcohol, hemiacetal or hemiketal, as a hydroxyl group and an oxygen with an R group. The carbon with the hydroxyl group in the alcohol is the carbon this oxygen is bonded to. I'll do this one, then I'm going to let you have fun too. And what do we have? Ooh, 2 organic molecules now. This first one, what's different? Carbonyl, carbon double bond to oxygen. And it could be a ketone, or if R prime is hydrogen, which it is, it's an aldehyde. And I'll call this my R double prime. Then carbon hydro, ooh, an alcohol. Acid catalyst is my R group. And what do you get? Keep your eye on the carbonyl carbon, because that's where the fun is. What's attached to it is still attached. Then it has a hydroxyl group, O, R. And that's this carbon. So I'm going to look at this carbon. What's attached to it? R prime, hydrogen. R double prime, ethyl. And here, notice I'll have a hydroxyl group, oxygen. What's my R group from the alcohol? Methyl. And that's how you do it. And now I'm going to let you have fun with one. As I mentioned, this is the next reaction Mother Nature uses to make carbohydrates and starches, which are a special form of carbohydrates. Your turn, give the organic product or products to the following reaction. And when you're done, give me a thumbs up. And when, like I said, when you're done, give me a thumbs up. Oh no, the thumbs up thing isn't working. Oh, it is. Thank you, Joanna. All right, my turn. Well, let me give you another 30 seconds and grab some water. All right, let's take a look at this. What's different? Ooh, carbonyl, carbon double bond to oxygen. And it's got carbons here and here. It's a ketone. Now, it could have been an aldehyde. And then what do we have here? Carbon, 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 hydroxyl group, and alcohol. And we have acid catalyst. And what do we get? Keep your eye on the carbonyl carbon. What's attached to it? R prime or H. Our double prime is still attached to it. The carbonyl carbon oxygen double bond has a hydroxyl group on this carbon, and then O and R from the alcohol. So do you break carbon-carbon single bonds? No. So this carbon, the ring with the methyl group is still going to be there. When I used to not teach the first year about you don't break carbon-carbon single bonds, students always broke rings and got it wrong. Here's my carbonyl carbon. This carbon, which is this carbon, which is this carbon right here. Therefore, you'll have a hydroxyl group, oxygen. What's R? Notice the N carbon has the hydroxyl group, carbon, carbon, carbon. I know there are four bonds to carbon. And there you go. And that's how you do it. And remember, you don't break carbon, carbon. I just got a nice message from someone. On carbon, carbon. single bonds. All right, let's move on. Now, you can react an aldehyde or ketone with now 2 molecules or moles of an alcohol and acid catalyst. Remember, coefficient of balanced chemical equation gives you the number of moles or molecules. Ooh, that reminds me. Does everybody remember a mole is Avogadro's number, 6.02 times 10 to the 23rd atoms or molecules? But a mole is a chemist counting unit. You know what my all-time favorite wish for a birthday gift is? My birthday is the end of December, so you got plenty of time to get ready for it. I would like a mole of pennies. It's just a mole of pennies. That'd be 6.02 times 10 to the 23rd. That'd be 100 million piles, and each pile had $1 billion, which I think is all the money on the planet right now, and could be on the planet. This is a mole of pennies. But anyways, don't forget about what a mole is. And here, let me rewrite this reaction a different way. One of these days I'll get unlazy and change that slide, but obviously not this summer. And what do you have? If I have a ketone or aldehyde, if R prime is hydrogen, it's aldehyde. If R prime is carbon, it's a ketone. And now we're going to react it with not one, but 2 molecules of alcohol. And what do you get? Keep your eye on the carbonyl carbon. What's attached to it, carbon-wise or hydrogen, is still attached to it. You open it up to the 2 oxygens, and now each oxygen has the R group from the alcohol. It turns out this is the reaction Mother Nature uses as a second step to make starches. You know, all the good things in life, potatoes, rice, French fries, pizza crust, you know, all that good stuff. Let's put it in action. And this one I'll do, and then you know I'm going to share. And the question is, give the organic product or products that are the following. And what do we have here? Oh, look, we have an aldehyde. Dr. White's getting lazy, I shouldn't. R prime is H, and we have an aldehyde. This is my R prime. This is my R double prime. Then we have here plus carbon, carbon, hydroxyl group on a carbon, alcohol. But not one, but 2. Don't forget the 2. Acid catalyst. And what do you get? Keep your eye on the carbonyl carbon. What's attached to it? Hydrogen carbons still attached to it. Then 2 oxygens. And each oxygen R group from the alcohol. So let's do this reaction. Here's my carbonyl carbon. That's what I'm going to draw first. What's attached to it? R prime, hydrogen. What else is attached to it? My methyl group. Then I'll have 2 oxygens, because that's what my general reaction shows me. What's my R group from the alcohol? What's attached to the hydroxyl group? Ethyl. And that's what you get. Now, when R prime is hydrogen, that's called an acetal. When R prime is carbon, it's a ketal. I'll never ask that on test, but I thought I'd let you know. And here, there is an IUPAC way of naming this, but I'm not going to cover it. I better share. There you go. Dr. White's sharing, letting you have some fun too. Have you noticed if I say enough times fun, you might think, wow, this is fun. Actually, it is. Give the organic product or products for the following 3 points each. And when you're done, give me a thumbs up. I see one thumb. I see two. I see a lot of them. All right, let's do it. Now, when we look at the first molecule, what's different? Remember, what's not a carbon-carbon single bond or carbon or hydrogen should get your attention like that. And I have an oxygen bonded to a carbon, carbonyl. It's got carbons here. Could have been a hydrogen, but it's not. It's got carbons here. This is my R group, doesn't make R prime. This is my R double prime. You can reverse and call the other ethyl R prime, methyl R double prime, doesn't make a difference. And then what, ooh, two. Carbon with a hydrox group, alcohol. And, ooh, excuse me, acid catalyst. Keep your eye on the carbonyl carbon because that's where the fun happens. Let me get that back on screen. And that's this carbon. What's attached to it, R prime or hydrogen. R double prime still stays attached to it. Then you'll have two oxygens and the R group on each oxygen from the alcohol. So here's my carbonyl. I'm going to drive that carbon first. What's attached to it, R prime, methyl. What else? Ethyl. Remember, you don't break carbon-carbon single bonds. Then my general reaction tells me I'll have two oxygens and each are, what is that? Methyl. And that's how you do it. Let's see if we can squeeze one more in. Let's have some fun. Here's one more to have fun with. And hopefully those of you are very proud of, hopefully all of you are proud that you're learning organic chemistry. 6 months ago, would you understood if I said, oh, a methyl or ethyl group? I see one person, Dawn. Don't forget to give me a thumbs up when you're done. I guess you could do a thumbs down, but if you don't have your video on, your webcam, I don't think they have emoji for that in Zoom. They should. All right. When you're done, give me a thumbs up. Those who finished early, please be patient. All right, I think everybody's done. Let's do it. What's different here? What's not carbon? What's not hydrogen? Ooh, oxygen or carbon-carbon single bond. And it's double bond to oxygen to hydrogen. I have R prime or H. In this case, this is H. And then attached to that are double prime, which is this carbon or methyl. And then, ooh, hydroxyl group on a carbon and two alcohol acid catalyst. And what do you get? Keep your eye on the carbonyl carbon because that's where the fun is. And what's attached to it, R prime or H, R double prime is there. And then you'll have two oxygens and then the R group from the alcohol. Remember, the carbon with the hydroxyl group is the carbon this oxygen is bonded to, and same thing for this one, this oxygen. So where do we start? The carbonyl there. I'm going to draw that carbon, what's attached to it, R prime, R double prime, two oxygens. What's my R group? Isopropyl. Center carbon of that is attached to the oxygen and the hydroxyl group, and it'll be attached to this oxygen. Oh, that's a fancy molecule. Dr. White's smiling now because it's pretty. Now you know I'm an organic chemist if he thinks that's pretty, and I do. And that's the product you get. Now, if I look at the clock, oh, I went a whole minute early, over, not early, late. Take 5 minutes. Let's take our break, and then we'll come back and do our lab because we're right on track. Remember, on Monday, Wednesday, we have lecture 50 minutes and lab. I'll see you in 5. Since I went over, actually almost 2 minutes. Why don't you come back at 1:57-ish? 1:57-ish, yeah, about that. And I'll see you in 5. I'm going to get up and stretch. Ooh, running a little late. Let's get going. I have to run to my kitchen, actually walk to get another bottle of water. All right, everybody, are y'all ready to get started again? And the answer is yes. All right, let's get going. It's lab time. And today's lab deals with distillation. My nose itch, sorry about that. And distillation is a way of purifying liquids. If you have two liquids that are different and you want pure liquid of one of the compounds or both, how do you do that? You do a distillation. And this lab is available for you to download on D2L. Now, since we're going to work with a hexane, if we're in the lab, you never, in fact, any organic lab nowadays, you never light a match, lighter, or Bunsen burner because they're flammable. Hexane is very flammable. All right. Now, all compounds that are liquids boil. And when a liquid of a compound boils, the vapor pressure of that liquid equals atmospheric pressure. And the temperature with this happens is called the boiling point. Now, when a liquid boils, the vapor of that liquid collects as bubbles. I think you've all seen water bubbling when you boil it. And those bubbles rise to the surface and collapse, and the vapor that's in those bubbles, the material on the liquid that's a gas, rises to the top. If you cool that vapor, the gas of the original compound, it will condense. That's what we use the word when it goes from a gas to a liquid to become a liquid. How many of you have ever taken a shower or bath in the winter? And in my case, since I have a skylight but no actual windows, the mirrors sometimes will fog up. Not anymore, because now I have, about a couple of years ago, I replaced the ceiling fan with a real good exhaust fan. But have you ever seen that? Or in the winter, sometimes you'll see your windows of your house get moisture, water on the inside. That's because the air is condensing in the air. You have water vapor, water in a gas form, condensing on the cold surface. And we use that in distillation. Now, warning, warning, I'm going to do some artwork. Try not to laugh too hard and hurt yourself when I'm drawing my artwork. My mother was a very good amateur artist. Not one bit of that rubbed off on me or I inherited. I'll never ever have the thought of going to art school. Not my thing. All right. Here we have and you can laugh, it's permitted. Laughing hard is also permitted. If we had water in a beaker, and here we have a hot plate, when you boil water, you'll see these little bubbles. And you've all done that in a pot. Now, a pot, metal pots or pans have even though it feels smooth, on a very highly magnified, almost molecular level, it's quite rough. However, glass is very smooth. And when you boil something in glass, whether it's in a beaker or other things, you have to put in boiling chips, or sometimes called boiling stones. At ECC, we use boiling chips because we spend more money than at COD. Don't tell anybody who said that. But anyways, these are rough, inert pieces, and at ECC, they're metal, carborundum, and they form a surface where the bubbles can form. If you don't have this, you get monster bubbles, and this all splashes out. We call that bumping. And that's bad. You don't want things to bump. So whenever you do heat and boil, which you do in a distillation, a liquid or mixture of liquids in glass, you have to put in boiling chips or it will bump and a lot of it will come out and you won't be able to purify it. Now let's look at the setup. For a distillation apparatus. And if we were in lab, you would be making this. Oh, that's sad. Let me make it a little smaller so you can see it. Too small. All right, now here's the distillation setup. Now, right here, these are called ground glass joints. And they help keep the different pieces of glassware together and sealed tight so no vapor can come through. Now you have to grease these so they come apart when you want to afterward, and you grease them with what we call high vac grease or vacuum grease, which I provide. And you just put a little line here, you don't want it. And by the way, this is called the male, this is called the female joint. And as in life, you put the male joint inside the female joint. And here we have another one set, and here too, and also right here. By the way, this setup, if we had been at ECC, I would warn you, be very careful with this stuff because the whole kit, which is in a black box, took me about 1.5 years to convince ECC to buy it. Back then was about $1,500 a kit. Now, I don't know, $2,500, $3,000. Ground glassware is expensive. Now, this flask right here is called a round bottom flask. Why? It's got a round bottom. And they can be real cute too. And now you know I'm a chemist. And on top, you have here the still head or the adapter head, and this is the thermometer. But a couple years ago, myself and Dr. Daly, who's the other organic chemist, he's also a lab manager, we were able to get thermocouples that hooked up to digital readout meters. So we came into the 21st or 22nd century, whatever, and you don't use the thermometer anymore. You use the digital thermometer called the thermocouple. Now, here's where you put your liquid, and you always put it in there with a funnel. I would teach you how to use a 3-prong clamp, and don't forget to put your boiling chips or stones in there. Otherwise, it's going to bump. And now when this is all closed together, what happens, first of all, is here's our condenser. And a condenser has an inner tube surrounded by an outer tube that they're separate. This is important. Water always goes in at the bottom of a condenser and comes out the top. because this way the water will fill this condenser. If we put it in the bottom, at the top, and out the bottom, the opposite, you'd only see water right here as opposed to filling the whole condenser up completely, and it wouldn't work as well. Now, the water you use is cold water, and when you heat this, the vapor comes up here, comes here, and becomes a liquid. It condenses and drops come down here, and you collect it. And we collect it in a graduated cylinder. Now, when you're heating this, important thing, for a round bottom, let me clean this up a little. Important safety consideration you should know. First of all, put the boiling chips in. When you have a round bottom flask, you never fill it about 2/3, maybe even 3/4 full of the liquid you're distilling. Why? How many of you ever cooked at home? You have a big pot and you put boiling water. So you're going to make, putting water to make boiling water for noodles, rice, or whatever, or you're cooking something in there. Do you fill it up all the way to the lip? No, it can boil over. Well, same thing with a round bottom. You never fill it up to the top. Now, another important safety consideration, you'll be heating it with, this is what it's called, a heating mantle. I just gave you a hands-on look of it. Is that cute now? Anyways, when you're heating a round bottom, just like at home, you don't let the pot go to dryness. In a lab, if you're heating organic chemicals to distill it, you don't want it to go dry. Why? Because it can heat up residue in there and it can explode. You never ever let a round bottom go dry. You always stop it so there's still some material in there, otherwise it could explode, which is not a good thing ever. So remember, water always goes at the bottom, out the top. This hose goes into the sink. The bottom one comes from the tap of a sink, and you just need a small flow. And you'll be doing the reaction with hexane. But let's take a look at the following. Give me a second while I set this up.
Hi, Verizon launched the first 5G network, and now we want to be the first to give everyone the joy.
I can skip the ad.
When performing a distillation, first the condenser is filled with cold running water. Next, heat is applied to the mixture which is to be distilled.
Everybody see that on the
The
screen?
mixture is heated until it boils,
Okay.
and the hot vapors will travel up to the distillation head. Measuring the temperature of the vapors helps us to identify the liquid being distilled and will help to confirm its purity. If the vapors are pure, they will have a constant temperature equal to the boiling point of the liquid being distilled. As the vapors travel into the condenser, they will be cooled and will liquefy. The liquid droplets, called the distillate, run down the condenser and are collected in a receiving flask. A liquid can easily be separated from non-volatile contaminants by using a simple distillation apparatus such as this one. Since the non-volatile components in the distillation flask will not evaporate, the vapors and the resulting condensate will be pure. This animation indicates that the temperature of the vapors measures the boiling point of the liquid. What exactly does boiling point mean?
Let's see what the other one looks like. It's been a while since.
Distillation is a separation technique that separates compounds on the basis of their boiling points. First, a round bottom flask is clamped to one ring stand. The flask must be large enough that the solution does not take up more than half the flask.
Actually 2/3. That's
A stir bar or boiling stone is added next. Here you can see one single boiling stone.
Actually, put in 2 or 3 are better.
The solution to be distilled is added after that. Once the solution has been added, a three-way adapter is attached to the round bottom flask. Notice that no ketal clip is added, as the high heat of the distilling vapor can melt it.
We don't use those clips.
On a separate ring stand, clamp the condenser sideways. A vacuum adapter is attached to the lower end of the condenser with a ketal clip.
We don't use those. The grease holds it in place.
Ensure the openings of the condenser are pointing up. Move the ring stands together in order to connect the three-way adapter with the condenser. Secure the connection with a ketal clip.
We don't need those.
A beaker is then placed under the open end of the vacuum adapter in order to collect the distillate. Attach the hoses to the condenser. The hose attached to the water is connected to the lower opening of the condenser, and the spare hose is attached to the upper opening of the condenser and directed to flow into the sink. When done correctly, water should flow up the condenser and into the sink. An iron ring is used to support the heating mantle, which is moved upward to snugly cup the round bottom flask. The cord of the heating mantle is tucked under the ledge of the hood and then plugged into the outlet under the ledge, where it can be controlled by the variac dial.
We have separate
The distillate
variacs.
should drop at a rate of 1 drop per second. If it is dripping faster than that, as shown here, the variac dial should be turned down.
Now, for yours, here's the procedure. You fill the round bottom with 30 milliliters of hexane, add about 3 to 5 boiling chips. In the lab, I show you how to use a powder funnel. And I asked to check it, and you slowly turn on the water. It's a trickle. If you do it too quick, guess what happens? The hoses pop off and you go home wet. You get an instant shower. I teach people this. Then you slowly heat it up with the heating mantle. Think of the heating mantle as like a very high temperature electric blanket, and it heats up the material to boiling point. Yeah. Then you start recording the temperature from the distillate, the vapor that comes over into a graduated cylinder. And when the temperature levels off, when you're collecting the material, that's the boiling point of that material. Like I say, this is used to determine or purify solutions or mixtures of materials. For this lab is just to give you an experience of doing a distillation, and we use pure hexane. And here's the data you would get in the lab. And after 2 milliliters It was this temperature, 4, 6, 8, 10. After 14, we stop. And you clean up. And here are questions for that. Now, remember, water always goes at the bottom and out the top of a condenser, so that way it fills it all up. You never, ever want to heat a liquid in glass without boiling chips or boiling stones in there, or it bumps. You never fill the condenser, the round bottom more than, they said, a half, now 2/3. Otherwise, this boils over like a pot over filled too high in your kitchen. And you never let the round bottom go to dryness. Now, unfortunately, and sad, Dr. White's sad, because you don't get to have the fun of building that. And that's the major part of the lab today, but you got to see how she put it together. And she did a pretty good job the second video. The only thing they didn't tell is each male joint you lubricate before you put it into the female glass joint. That way later on you can pull them apart. And with that, I'm done. That's today's lab. Don't forget the lab we did last Wednesday is due today, and this lab will be due Wednesday. And with that, I'm going to say, gang gesund. Goodbye. I'll see you tomorrow.